Okay, another Wireshark activity, using Wireshark to examine Ethernet frames. Let's see. So required resources is our own PC. So objectives is part 1, examine the header fields in an Ethernet 2 frame. Okay, and then part 2 is use Wireshark to capture and analyze Ethernet frames. Background scenario, so when the upper layer protocols communicate with each other, the data flows down the OSI layers and is encapsulated into layer 2 frame. Okay, so on our data link frame, so the frame composition is dependent on the media access type. Okay, so for example, if the upper layer protocols are TCP and IP and the media access is Ethernet, then the layer 2 frame encapsulation will be Ethernet 2. So this is typical for LAN environment. So when learning about layer 2 concepts, it is helpful to analyze frame header information. So in the first part of this lab, you will review the fields contained in an Ethernet 2 frame. So in part 2, you will use Wireshark to capture and analyze Ethernet 2 frame header fields for local and remote traffic. Okay, this is for remote network. So required resources, so one PC. So we'll be using our desktop. So we are operating in Windows 7 and with internet access. Part 1 is examine the header fields in an Ethernet 2 frame. So in part 1, you will examine the header fields and content in an Ethernet 2 frame. So Wireshark capture will be used to examine the contents in those fields. Okay. Step 1 is review the Ethernet 2 header field description and links. Okay, we have the preamble. So the first section in the Ethernet 2 header. So it's 8 bytes. So its size is 8 bytes. Destination address, so it is 6 bytes. Then source address, so also it's 6 bytes. 6 bytes, or how many bits? So 48 bits of source address. Okay. Then frame type, so it's 2 bytes. Data 46 to 15 bytes, and the frame checking sequence, frame checker, so 4 bytes. So examine the network configuration on the PC. This PC host address is okay, we will be, so let's see, CMD. We will be using ipconfig all. Okay, we will be needing the information here later on. Okay, so examine Ethernet frames in Wireshark capture. Okay, this is a Wireshark capture generated by a ping issued from a PC to its default gateway. So a filter has been applied to Wireshark to view ARP and ICMP protocols only. So the sessions begin with ARP query for the MAC address of the gateway router, followed by 4 ping requests and replies. Okay. So the PC request for the MAC address of the gateway router, now it sends an ARP request. So it is a broadcast address. Okay, now it replies, the default gateway replies with its MAC address. Then examine the Ethernet 2 header contents of an ARP request. So the following table takes the first frame, the Wireshark capture, and displays the data in the Ethernet 2 header frames. Okay. So this table here contains the fields, values, and description of the ARP request by our PC, or by the PC here in the example. So preamble, so it's not showing the capture. So it contains synchronizing bits processed by the NIC hardware. So destination address, so it's a broadcast address. Source address, so it's the, I think this is the source address. Is this okay, this is source MAC address. Ano? Source MAC address. Source MAC address of the host. Okay. Because okay. That's why we have 6 bytes here, a 48-bit address. It's because of our MAC address. So I thought it was the IP address. Okay, we're dealing with layer 2 addresses. Okay. So each address is 48 bits. Okay, for common format. So we're using colons. So the first 6 hex numbers indicate the manufacturer of the NIC. So for example, 12 this. So it's the OI, the vendor. Now the last part is, so it is a serial number of NIC. So it's a unique address now. So the destination address may be broadcast, so which contain all ones or unicast. And then the source address is always unicast. Okay. Frame type, so it is 806. So the value is 806. So for Ethernet 2 frames, this will contain a hexadecimal value that is used to indicate a type of upper layer protocol in the data field. So there are numerous upper layer protocols supported by Ethernet 2. Okay, the most common frame types are these values. So the hexadecimal 800, so it is an hexadecimal, and 806. So if it's 800, we have the IPv4 protocol. Then for 806, we have the ARP, so address resolution protocol. So we have a value of 806 because we're using the ARP. No? The data, it's ARP, contains encapsulation upper level protocol. So it contains the data. The FCS is not shown the capture. Frame check sequence to identify errors during transmission. Okay. So what is significant about the contents of destination address field? So it is it's a broadcast message. No? Then why does the PC send out broadcast ARP prior to sending the first ping request? So because the PC doesn't know the MAC address of the default gateway, so it sends ARP request containing the IP address of the default gateway, and then the default gateway will reply its MAC address, so which is the now have the destination address of the PC. So what is the MAC address of the source in the first place? What is the MAC address? MAC address. So you have this one. That is the MAC address. 4091.82.9F6B86. So what is the vendor ID or UI? So we have this first 6 hex now. Hex bits. 4091.82. What portion of the MAC address is the OUI? So we have this first 6 numbers. So what is the unique serial number of the source? So we have the 9F6B86. So it is a unique address or unique numbers. Now for the part 2, we will use Wireshark to capture and analyze Ethernet frames. So in part 2, you will use Wireshark to capture local and remote Ethernet frames. You will then examine the information that is contained in the frame header fields. Okay, determine the IP address of the default gateway on your PC. Okay, we will issue the command ipconfig command on our command prompt, and the IP address of our default gateway is the 192.168.1.1. Okay, that is our default gateway. That is our interface address of our home router. Okay, close Wireshark. What? Open Wireshark. Okay, let's see. Wireshark. Then we will be using this. No. Let's see. This one. No. Back. Let's see. Filter Wireshark to display only. Okay, news. Okay, we will be using the ICMP. ICMP only. So, okay. So, from the command prompt window, ping the default gateway of your PC. Okay. Let's see. Ping 192.168.1.1. Okay. Okay. Then, click stop capture. Capture stop. Next, so examine the first echo or ping request in Wireshark. Okay, the mesh is divided into. So if you selected the correct interface for packet capturing in step 3, okay, Wireshark should display ICMP information in the packet list ping. Okay. So let's see. So in the packet list ping top section, click the first ping listed. You'll see ping request under the info heading. Okay. So we'll be using this ping request. Oh, okay. So examine the first line, the packet details page. Middle section. This line displays the length of the frame. Okay. So we have 74 bytes. That is our length. Next. So the second line in the packet details pane shows that it is an Ethernet 2 frame. The source and destination MAC addresses are also displayed. Okay, what is the MAC address of the PC and IC? And then the gateway MAC address. Okay, we have our source MAC address. Okay, this is our NIC's MAC address, and then the baud tech. So this one is our destination MAC address. This is the MAC address of our home router. So you can click plus sign at the beginning of the second line to obtain more information about the Ethernet 2 frame. Notice the plus sign changes to white sign. What type of frame is displayed? Let's see. We have IPv4. Okay, so 0800. So it's not an ARP. So ARP is 806. Okay, the last two lines displayed in the middle section provide information about the data field of the frame. So notice that the data contains a source and destination IPv4 address. Okay, the source IPv4 address is so our source IP address is 192.168.1.7, and our destination IP address is 192.168.1.1. Okay. So this is for data field. So you can click and line in the middle section to highlight the part of the frame. Okay. Click the ICMP.
Walang mga love story.
And line in the middle section to highlight the part of it. So click the ICMP protocol, ICMP line in the middle section, and examine what is highlighted.
Wala daw siyang crash landed doon.
ICMP protocol. Okay. So this one. This is the highlighted. So we have here some of the highlighted numbers. Next, what do the last two highlighted octet spell? Plus
Ano
2.
ka na mag, sikreto te. Tapos ang bibibigyan. Ito ba niya? Ang bibibigyan.
Okay naman. Okay, what be the last highlighted of that spell? Let's see. Warp CFG F5. So it's also the same with okay. So click the next frame in the top section and examine an ARP echo reply frame. So notice that the source and destination MAC address have reversed. So because this frame was sent from the our router as a reply to the first frame. Okay, what device and MAC address is displayed as the destination address. Okay, so we have our PC. Let's see. So we are on the reply. So now our destination IP address is so 192.168.1.7. This is our IP address of our desktop. And then destination MAC address is a gigabyte. So this is our MAC address of our NIC's card. So next, restart packet capturing Wireshark. Okay, we will see pop-up. Okay, we will now ping this is code.com. Continue without saving. Okay, now ping cisco.com. You can't find it. Earlier we can find it there. Cisco.com. Or we don't have an internet. Let's see. We have an internet. That's why we can't access it. We don't have an internet connection. Okay, we don't have an internet connection, so we can ping the cisco.com. So the first ping request, what are the source and destination MAC address? So the source MAC address would be our MAC address, our NIC's card MAC address, and then the destination would be the MAC address of our router. So what are the source and destination IP address? Okay, so our source IP address, so it is our own IP address, 192.168.1.7, and then our destination address would be the IP address of cisco.com, so converted by the DNS. Now compare this address to the addresses you received in step 6. The only difference that changed is the destination IP address. So why has the destination IP address changed? Or the destination remained the same? Why has the destination IP address? Step 6. This game is the step 6. There's no step 6. Okay. So we're pinging. Okay. So the first one is we ping the. Okay, we don't have an internet. Our upload will be cancelled again. Okay, now we will be able to ping this. Okay, we are able to ping this cisco.com. We already have our internet connection. Okay. Okay, we have the source. Okay, destination IP address. Okay. So our request to this one. Okay, the destination would be. Okay, the destination IP address is our MAC address of our router. But we have the source IP address, our layer 3 address, as the IP address of cisco.com. So because destination IP address change, the destination MAC address remain the same. Okay. So because on step 6, we ping the default gateway, and then we need the IP address of our default gateway. Then on the second one, we use the IP address of cisco.com. But when accessing the remote a host in remote network, we use the destination MAC address of we use the MAC address of the router. Okay. So when it travels around the network, so the layer 2 frame was changed to the next hop router. Okay. So Wireshark does not display preamble field. What does the preamble contain? So according to this table, so it contains synchronizing bits processed by the NIC card. So preamble contains the introduction. So mostly the introduction of the transmission. So it's a series of bits, 10 bits. Okay. So that's it.